Let's look at OpenStax College Physics, Chapter 18, Problem 16. A test charge of plus 2 microcoulombs is placed halfway between a charge of plus 6 microcoulombs and another of plus 4 microcoulombs, separated by 10 centimeters. A. What is the magnitude of the force on the test charge? And B. What is the direction of this force, away from or toward the plus 6 microcoulomb charge? So let's write down the things that we know, and I already drew a diagram here. So I'm going to call the 6 microcoulomb charge Q1. So I have Q1 is plus 6 microcoulombs. I'm going to call the plus 4 microcoulombs charge Q3. So Q3 is plus 4 microcoulombs. And the test charge is going to be Q2. So that is plus 2 microcoulombs. We know that the separation between charges Q1 and Q3 is D, and that is 10 centimeters. And in part A, we're looking for the magnitude of the force on Q2. And in part B, we're looking for the direction of force F on Q2. All right, so we're going to use superposition on charge Q2 by figuring out the force that it experiences due to charge Q1 and the force that it experiences due to charge Q3. And then we will solve for the net force that acts on Q2. So we know that both Q1 and Q2 are positive charges, which means that Q1 will repel Q2, so Q2 will want to go to the right. And then since charge Q2 and Q3 are also positive charges, Q2 will be repelled by Q3, so Q2 would want to go to the left due to charge Q3. So then we have a force, I'm going to call that F of 1 on 2, so force due to charge 1 on charge 2, and I'm going to have another force, and I'm going to call that force due to charge 3 onto charge 2, and they are in opposite directions. So I will pick my positive x direction to be to the right, which means that this force will be positive, this force will be negative. And I will have to find the net force, so I'm going to use F12 minus F32 for my net force. So I'll write sum of the forces on charge 2 is F12 minus F32. So by using Coulomb's law, F12 is K, absolute value of Q1, absolute value of Q2, divided by the separation between them squared, and that is D over 2 quantity squared, minus K, so now I have force 3,2, so that is charge 3 times charge 2 divided by the separation, which is also D over 2 quantity squared. So I can factor some things out to simplify the calculations. So I have 4K over D squared, absolute value of Q2, times absolute value of Q1 minus absolute value of Q3. So that is 4 times 9 times 10 to the 9th divided by D squared, which is 0.1 meter quantity squared. Q2 is 2 times 10 to the negative 6 coulombs. And then Q1 is 6 times 10 to the negative 6 coulombs. And Q3 is 4 times 10 to the negative 6 coulombs. And when we plug the numbers into our calculators, we end up with 14.14 newtons. And if we wanted to use sig figs, since they only have one sig fig each, then this would be 10 newtons. So this is the force that charge 2 experiences due to charge 1 and 3. Now, we answered part A. In part B, we want a direction. So how do we determine that? Well, since I picked the positive direction to be to the right, and I obtained a positive number, that means that my final force is also to the right. And the question is asking us to say whether it is toward or away from the 6 microcoulomb charge. And since it's to the right, that means that it's away from the 6 microcoulomb charge. So in part B, I will say F on Q2 is away from the plus 6 microcoulomb charge.